Hi everyone, welcome back to Pilot's Data 5-minute CPL and ATPL crack video. In this video, we are going to look for a CP problem. The one which we are going to look now as a very basic CP problem or point of equal time problem, because there are 2 to 3 types of CP problems. I have mentioned type 1 here. We will be seeing type 2 and type 3 in my following videos. As the type number increases, the difficulty level for finding the CP will also increase. Okay. So for doing a CP problem, you need 2 things. First one is a flight computer, that is CX3. The other one is a scientific calculator. Don't worry, these 2 are allowed for DGCA navigation exams. So I just want to make sure that you guys are clear with the theory part. I have made a video about the theory part for the CP. So if you want, you can view that in my description. I have given the link there. Okay. So let's start. So let's read the questions carefully. An aircraft is flying from A to B. Distance from A to B is given by 800 nautical mile. Track is 330 degree. Wind is 120 degree, 28 knots. True airspeed is 220 knots, that is normal, and 160 knots, that is reduced. Because when it comes to CP, as I told you, we are assuming there is an engine failure at CP. Okay, I have mentioned, I have cleared the things about this in my theory part video. So when it is mentioned normal, that means the aircraft is running on full engine. That is, if it is 4 engine aircraft, all the 4 engines are working. If it is 2 engine aircraft, then 2 engines are working. When at full, all the engines are working, then the true airspeed will be this one. And when there is an engine failure, that is, if it is a 4 engine aircraft, 3 engine will be working. If it is a 2 engine aircraft, only 1 engine will be working. That is given by reduced one. Okay, in some questions, for giving normal, it will be given that 4 engine, and it will be given 3 engine or 2 engine and 1 engine. Okay, both are same. Then fuel on board is given by 1600 kg. Reserve fuel is given by 300 kg. Fuel consumption is given by 290 kg per hour. Again, normal is given, that means with full engine running. These 2 are linked. To take 200 kg per hour, it is reduced, that is with a reduced engine or 1 engine failure situation. So we are asked to find DPET O and TPET, that is distance to point of equal time and time to point of equal time. Again, point of equal time and CP are same. CP is same as point of equal time. I'll be using CP because I am used with the term CP rather than PET. Don't get confused, both are same. So let's start with the formula first. dCP is given by dH by O plus H. Right, we have seen this in the theory part. So D is directly given, that is 800 nautical mile. Right, so from A to B, it is 800 nautical mile. Suppose we are considering CPS at the midpoint. We have seen at the theory part, to find H and O, how H and O is represented, we need H and O to find the problem, to solve the problem. So what is H and O? We have seen it. O is given by outbound, right? This is O, and H is given by homebound, right? You have seen the theory. So we have to find H and O. What is H and O actually? It is the ground speed. So let's see. So we have to find H and we have to find O. So for doing that, the easiest method is to draw a table. Let's see, we have to find the leg. We have to mention the first one as leg. That is, we have to find H. We are going to look for H right now. That is a homebound. So leg is from CP to A. Okay, CP to A. Okay, true airspeed. What is the true airspeed? As I told you, in this one, from CP to A, that is, we have reached the aircraft. We are assuming that the aircraft has reached the CP and it is returning back to home. That means it is coming back at reduced task because we assume that there is an engine failure at CP. So reduced task will be 160 knots. Then track. What is track right now? We have given distance from A to B is 800 nautical mile and track is 330 degree. So that means that when the aircraft travels from A to B, it is maintaining a track of 330 degree. What happens if the aircraft is returning back from B to A? That means the reciprocal of 330 degree, that is 150 degree. Right? Don't get it confused or don't get it wrong, because the most common mistake is this one. When we take the heading, there will be mistake. Okay. So from CP to A, we are maintaining a track of 150 degree. So 150 degree. Then wind velocity. What is the wind velocity? It's fixed at 120 degree at 28 knots. Now we have to get the ground speed. Just take the flight computer. We'll see. In flight computer, just take the wind correction. In this one, input the value. True airspeed is 160. Course is 150. Okay. The thing to be noted is that in the flight computer we have given course and heading. Actually, the one which is given to us is the track. It's not the heading. That's why we are inputting in course section here rather than the heading section. Okay. So just put the track in the course field. Then wind speed is given by 28 and wind direction is 120. After inputting, we get the ground speed as 135 knots. 135 knots. Okay. So we got the home ground speed, OH ground speed, 135 knots. Now we are going to look at O. What is the direction? What is the leg actually? O is CP to B. CP to B. What is the true airspeed? Again, with a reduced task, track will be entirely different. In this case, we are traveling from CP to B, that is 330 degree, the opposite of this one. 330 degree. Wind velocity is same, 120 degree, 28 knots. Let's input the value in the flight computer. We'll see. True airspeed is 160 degrees, same. Wind speed is 28. Wind direction is 120. Forgot to input the course because it's 330. So we get the ground speed 184 knots. Okay, we got it 183.64. I round it as 184. So we got the O as well as 184 knots. So we got all the values, just input it directly here. So DCP is given by D is 800, H is 135, O is 184 plus 135. Okay, just use your scientific calculator for EC. 800 into 135 divided by 184 plus 135 will give you 338 nautical mile. Clear? That means we got the CP at around here. CP, that is around 338 nautical mile from A. Okay, so let's look at TPET right now. TPET is given by the formula dCP by the ground speed. Ground speed from the starting point to CP. In this case, we are taking from A to CP. For finding ground speed, we have to follow the same method. In this case, we will look at the leg first. Leg is from A to CP. I have cleared it in the theory part why we are taking from A to CP. So let's see A to CP. So the task which we are taking here, or the true airspeed which we are taking, is the actual true airspeed or the normal airspeed. Why? Because from A to CP there is no engine failure. As I told you, we are taking or assuming an engine failure at CP. So when we are traveling from A to CP, there is no engine failure. So that's why we are taking the full task or normal task to 20 degree. What will be the track? We are traveling from A to CP. A to CP here. So the track is 330 degree. 330 degree. Wind is the same, and 20 degree, 28 knots. Let's put the values here. True airspeed is 220. Course is 330. Wind speed is 28. And direction is 120. We'll get it as 243.8. We'll round it as 244 knots. Okay. So we'll put the values here. We already got the DCP, that is 338 nautical mile divided by ground speed, which got is 244. Let's put it in the scientific calculator. That is 338 divided by 244. Okay. That will give you 1 hour 23 minutes. 1 hour 23 minutes. Okay. So that's it for DCP and TPET. Okay. Time to point of equal time. This is a simple one. So one thing I want to convey is that we are not taking any terms from fuel on board or reserve fuel consumption, because when it comes to CP, as I explained in my theory part, fuel of any type will not affect DCP or TCP, or distance to point of equal time, or time to point of equal time. These are given to find the PNR, that which we'll be looking at in the following videos. That is point of no return. Okay, for finding CP, we don't need these values. Okay, so anyway, I hope you got this clear. Thank you for watching the video. Thank you. Bye.